Homozygous recessive short plant. What does that make you think? What does the word homozygous mean? The same. Recessive means if it only shows up if the dominant's not there. Correct? So usually that means lowercase. And it means you need 2 times the alleles to get it, to see it. So you need 2 copies of it to see it. So every recessive, if something's recessive, if it shows a recessive trait, it's homozygous, correct? Yeah. All right, because if it's showing the recessive trait, it's homozygous. So it says cross a homozygous recessive short plant. So if it's going to be short, I'm going to put big T for tall. That's what I'm thinking. I'm automatically thinking what letter. I'm making my key. First thing I do is I take apart the paragraph. This is where most people mess up, right at the beginning. Most people get this wrong, get the problem wrong in the first few sentences. So you have to ask yourself, break up the paragraph into parts. So tall, you can pick whatever letter you want, I don't care, but the dominant version's tall. The recessive version is short. And this plant happens to be recessive, so I know this is at least half of its genome. Then it says the short plant with heterozygous purple flowers. Heterozygous means what? Which means there's going to have 2 of them, right? Where the homozygous is either, let's say, big A, or little a, right? Heterozygous would be what? Big A, little a. No, big A is homozygous. So it would be big A, little a, right? And if purple is, let's say purple color, is heterozygous, they told you that, right? Literally were the words that were used in the problem are heterozygous. It would be something like this, correct? So what's dominant? Purple. So purple's dominant. So PP would also be purple. And they don't tell you the other color, but you know that little p would be not purple. Some color that's not purple. Of course, if big T, anything, big T, little t, or big T is tall. Are we good? That's all I need to know to answer this question. I mean, that's the only key I need. Question? Yeah. Yeah, you can sit wherever you need, darling. Any room, any seat when it comes to... Sit where you got to sit to see. So you made the key for your traits. Now you got we know that it's homozygous tall, homozygous recessive short, and heterozygous purple. That means that the purple looks like this. So that's one parent. Now I know what one parent looks like, their genes look like. Then it says, what will be expected? Oh, wait, sorry. Heterozygous for tall and heterozygous for purple. Well, I look at my key. Tall is big T at least. It's heterozygous, little t. And heterozygous for purple is so. Why do they say heterozygous for tall and heterozygous for purple? Because it could be homozygous, right? There has to be a clue there to tell you what's going on. Notice I figured out the purple was dominant because whatever the heterozygous shows is the dominant trait. Okay. So these two are being crossed. So the first question comes to mind is how many different genotypically different gametes can this creature produce? And how many different genotypically different gametes can this creature produce? That's kind of a really essential piece of the problem. Genotypically different. So this one can produce, remember we're going to do foil. First, little t, big P, outer, little t, little p, inner, little t, big P, and last, little t, little p. Do you see that? Do you see that this one and this one, this one and this one are the same?
Yes.
And do you say that this one, do you see they're the same?
Yes.
So we don't have to do these because they're the same. If they're different, then you have to use them. But I don't have to use them. It's going to reduce my confusion. I cannot tell you how many of these practice sheets I've seen where you guys try to do a 4x4, you fill out all 16, and you get lost in the weeds. You keep counting, you count incorrectly. You're looking at you're counting something that's tall and purple when it's short and whatever. Okay? So just keep it as simple as you can throughout as to how you make neatness and simplicity leads to the correct answer here. So what are the possible gametes here? I'm just going to write them rather than doing foil. It's big T, big P. It's little t. I'm sorry. Let me keep them together. Big T, little p. It's little t, big P, and it's little t, little p. So these are the four possible gametes that this creature can produce, where this one can only produce two. So I'm going to take this. I'm going to put it on one part of the Punnett square. And I'm going to take these two. I'm going to be on the other part of the Punnett square. T, P, T, P, T, P, and T, P. Then I'm going to use little t, big P, little t, little p. Now we're going to go ahead and fill in make the zygotes. Remember, these are gametes. They only have half the necessary genes. What do sperm and eggs do? They combine. They fuse. So let's combine these. Big T, big P, little, I'm sorry, let me write this smaller. Big T, big P, big P. Big T, big P, little p. Little t, oops. Little t, big P, big P. Little t, big P, little p. Big T, big P, little p. Big T, little. See, this is real easy. You all agree? The mistake is going to come when you accidentally write a big P or a little p. You're not neat. You don't make it clear which one's capital, which one's lowercase because you're writing quickly. Then you're lost. You're not going to get the right answer. Hard to recover from a lack of organization here. So now it's time for counting. Counting can be very hard if you're not doing it carefully and systematically. The way I like to do it is I make little symbols for myself so I don't make mistakes. So tall and purple. This is tall and purple. Notice there's two different genotypes. Do you agree? These two zygotes are different, but they're both tall and purple. Tall and purple. And that's it. So there's 3 tall and purple. Then you have short and purple. Let's see, you got short and purple here, short and purple here, and short and purple here. So there's 3 short and purple. Then you have tall and non-purple. Well, this is tall and non-purple. And then you have short and non-purple. So now it's easy for me to count, isn't it? Now I don't have to make mistakes, little mistakes that cost me 200 points. Obviously, I hope it's obvious. This is one of these, and this is one of these. So now my ratio of different phenotypes is 3 to 3 to 1 to 1. That's it. That's my answer. That's my answer because that's the ratio of tall purple to short purple to tall non-purple to short non-purple. 3 to 3 to 1 to 1. Now, the answer choices were 9 to 3 to 3 to 1. Is that something that could be the answer according to my work? 9 to 3 to 3 to 1 would work for this? No, it would not. 4 to 4 to 2 to 2. Why do you say yeah? But why yeah? What were you thinking when you said yeah? Just out of curiosity, I want to understand you. Why did you say that? You just kind of just came out. You just said yeah. There has to be a reason.
Because it's 3 to 3 and 1 to 1. 4 to 4 and 2. I don't know if this one.
You just kind of brain fart. It happens to me all the time. I'm just asking. All right, so that has nothing to do with that. So how about 1 to 2 to 1 to 2 to 4 to 2 to 1 to 2 to 1? That doesn't make any sense at all. How about 3 to 1 to 3 to 1? Yeah, that's right. Why is the order of the numbers different from 3 to 3 to 1 to 1? Because they gave you 3 tall and purple, 1 tall and non-purple, 3 short and purple, and 1 short non-purple. They just put them in different order. But the number of each phenotype is going to be the same. The only right answer is 3 to 1 to 3 to 1. Are we clear? If you picked anything else, it was just guesswork? What do you think? Why? Can someone volunteer why they chose any of the other answers? Yeah, which one did you choose? Which ratio?
The last one.
The last one, 1 to 2 to 1 to 2 to 4 to 2 to 1 to 2 to 1. That means what you said when you picked that is there 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 different phenotypes though. Do you understand what this ratio means?
I know it didn't make any sense, but at the last minute I just.
Oh, so it's a guess. It's just a complete guess. That's okay. I just want to know. I want to understand why you chose it. Anybody else? Anybody want to volunteer why they chose any other answer other than 3 3 to 1 to 3 to 1? Yeah.
I did all the steps correct, but I didn't know how to like count it because like that was the only mistake.
That was a mistake. So this helped you when we
Yeah.
looked at kind of making it. Did the steps help? I mean, obviously it helped about 2/3 of the class that got 100% because you followed the steps that helped you. But the rest of you that didn't get it right, are you on at least in the ballpark? Do you have a good foundation? Yes? Okay. So let's go on with the rest of the worksheets. Remember, you're going to get almost a very similar problem tomorrow. When you walk in here, you'll get a similar problem. Get it done. You get 200 points there. You get 200 points for both days. All right? All right.